starting a minute late. I will make sure to go a minute late. Right? Don't want to deprive you. I will begin. With a word of prayer. So, I have hemmed. Dear Father, we thank you for this day. Again, I thank you for your many blessings to us. I pray that you be glorified in what we do this day. And we just thank you for math and for your beautiful creation, Lord. In your name I pray. Amen.
1645.
Yeah. So today we are talking about inequalities. But before I do that, just a couple of words about bookkeeping and such. So I had the email that I put in my labs. I had forgot to change it from my previous institution. So like if you sent me any emails, it was going to my previous institution's email, which I wasn't checking. So if you sent me a message through like, ask your instructor or whatever, I really didn't see it. Going forward though, I have changed the email so it's my Liberty email, so I should see your messages going forward. Now if you send me a message or something and I don't respond to it within a day, you should email me, because I do try to respond to messages within a day. So if I didn't, that probably means I didn't see it, all right? And that's just a general point of order here at Liberty. There are times when the email system just eats things and it chews on them for months, and then it sends them out like 3 months later. So every so often I'll get an email around Christmas that was from like the start of the semester from some student. I'll be like, oh, what? Now that student doesn't know that I never got their email, right? They just think I've been ignoring them, but I haven't been. It's just that the email ate it. So when you send something to some professor here and you feel like they're ignoring you, don't assume that is necessarily the case. Send them another email after a day or two. Hey, did you get my email? Or just attack them. No attacking professors. Isn't that part of orientation? No, professors are people too. You cannot harass them. No hazing professors either.
Just go egg your car.
Just go egg my car. First you have to find it. It's not that easy. Let's see here. The one with the math license plate? Not anymore. Once upon a time. All right, so inequalities. Are there any questions about anything? So let's talk about inequalities and interval. Yep.
I do have a question.
Go for it.
Would it be okay if you went through all the steps necessary to solve an equation or a problem, and not kind of skip, just so we know how to do it and then?
Well, if there's a particular step you don't understand, you can ask me about that. But I mean, I can always. My experience though is that if I put all of the possible steps in, it confuses students. So like, I typically, for example, I might have a problem where I show 4 steps. I could easily expand that to 12 steps. In the process of doing that, I would confuse everyone, because everyone would start asking me, do I have to show all those steps? And then I'd be like, well, no. How many steps do you have to show? Well, I show you a minimal set of steps when I write things on the board. If there's a given step you don't understand, like feel free to like jump in and say, hey, I don't understand how you went from there to there, and I'll expand on that. All right, but I'm not going to put a maximal set of steps in every example, because it's detrimental to more people on the average of things. But it's a fair question. I think I'm erasing the board with my shirt. Probably should stop. So let's start with interval notation here. That said, I think you'll be happier with today. There's going to be more steps today than previous 6 classes. So, number line. Number line. Number line. Number line. Number line. Number line. So I'm going to draw some pictures. I'll start with this one. If we have a picture like this, right, going from A to B, and so X is a typical point in here, then we could write X is an element of A to B. What does this mean? This is the set such that x such that a is less than x is less than b. Right. So this, let me just expand some things here. This means element of. This right here is read such that. Right? So the a comma b, this is the so-called interval notation, right? Interval notation is more often than not what we ask you to write your answers in, using interval notation. So, but this picture is really interchangeable with this sentence over here. X is an element of the open interval from a to b. That means x such that a is less than x is less than b. Now, we could also do like this. And, you know, so my typical x would be somewhere in there, right? And then for that, I could say x is an element of closed interval from a to b. What that means is x such that a is less than or equal to x is less than or equal to b. It's another possibility. We could also have something like this, right? We could have open on that side and closed on the other. So like it excludes a, but it includes b. And this would be something like x is an element of a comma b, like that. And this would be x such that a is less than x, which is less than or equal to b. There are yet more flavor choices. What else can I do? Yeah, I'm not going to do that though. What's that? All the way? Okay. Okay, so like this, for example.
The whole line, infinity to
So that would mean x is an element of what? A to infinity. I mean, you guys were telling me do the other case. Fine. There's like 9 cases. I'm only going to write down 5 of them, okay? Wait a minute. 6 of them. So x is an element of a to infinity. This would be x such that x is greater than a, if you like. Or we could do like include a, but go to minus infinity, right? So that would be x is an element of minus infinity to a, this time a is included, right? And that would be like x such that x is less than or equal to a. And then there's one other case I sometimes forget, but how about yeah?
the open one.
Yeah, everything, right? The whole deal, right? So x is an element from minus infinity to infinity, right? Our other notation for this is just r, which is, this is the whole set of real numbers.
What if the number line is empty?
The number line is empty. If the answer is nothing, empty set. Either people tend to use this symbol or just curly brackets like that. Now that you got me started, if you got just 1 point, like this, right? That's your whole set. If that's at A, then this is just the set just containing A. Sometimes that happens.
2 dots.
As part of your, yeah, if you had 2 dots, you can put 2 things in there. All right. Okay, so what are the laws of inequalities? So I would first of all say this: A less than or equal to B is interchangeable with B greater than or equal to A. Right? First of all, you can flip left to right and right to left if you trade less than for greater than, right? And vice versa. So you got that. The other thing we can do is we can if we have a less than or equal to b, then a plus or minus c is less than or equal to b plus or minus c. In other words, you can add or subtract across an inequality. Okay? So we can add or subtract both sides of an inequality. Multiplication or division is where it gets tricky, right? So if c is positive and a is less than or equal to b, that implies that ca is less than or equal to cb. However, if c is less than 0, yeah, we flip the sign. Ah. So these are the basic rules. All right? So let's try to put these into practice and solve some inequalities, right? So like example 1. Suppose we want to solve, I don't know, 3 minus 2x greater than 8. How do you guys want to solve it? You subtract 3 from both sides? Okay. I like it. I'll do it. Minus 3, minus 3. So we get minus 2x greater than 5. Now, what I would say next is we want to divide by minus 2, aka multiply by what? Minus a half, right? So really it falls under multiplication that I wrote above. So I've minus 2x over minus 2 is less than 5 over minus 2. Why less than? Because I am multiplying, or I'm dividing by a negative number here. Right? Whether you multiply or you divide, either way you want to look at it, if you're multiplying or dividing by something that's negative, you flip the inequality, which is what I just did. So this gives us x is less than minus 5 over 2.
Multiply or divide.
Yeah, multiply or divide. I mean, because remember, division is just multiplication by the reciprocal, so they're really the same animal, you know? So either multiply or divide by a negative number flips the inequality. That's right. Okay, so what's the answer? If we drew a number line picture, it'd be what? Something like this, right? We've got minus 5 halves, and it just goes on and on, right? So the answer is minus infinity to minus 5 halves, not included, just like that. There's the solution set. So when we're solving an inequality, we don't just get one answer typically, right? We get a whole string of answers, so we have to use this interval notation to express the answer. In contrast, we're solving quadratic equations or linear equations, maybe we just got one answer, right? Or the ones that were from, like, you guys enjoyed Friday class last week, right? You guys enjoyed that class? Okay. Shouldn't be so happy about it. But I would, in some sense, rather have been here. We'd already closed down the house, and I was sleeping on my ex-Sunday school teacher's couch. And then I woke up, he was standing over me with a blanket about like this. And the thing is, you gotta know Mr. Bobby, like an ordinary person would just drape the blanket over you, cover your head, go ha ha ha. No, that's not where Mr. Bobby's going to stop. I knew that I had seconds before that blanket was over me and he was crushing me. I could feel it was coming. I escaped though, just in time. So it was, I was in a state of moral danger not teaching class last Friday.
How did your house go?
We sold it. Woo-hoo. So, yes, thank you. So, yeah, selling a house is no fun. So that's that. So we have different ways to express the answer, either as a number line picture, right? Or using the interval notation. Or, of course, in some sense, right, if you could just find like this, if you can isolate x and just write a sentence involving inequalities, that's also a way to write the answer, right? Yeah. Example 2.
On the test, will we have to write just like solution set? Or?
I probably will ask you to express your answer using interval notation.
Okay.
And then I'll take off like 30% if you don't. Or more, depending on how annoying it is for you not to have used interval notation. Actually, it kind of depends on, if you don't use interval notation, like the question is how much daylight is there between your answer and the correct answer? I mean, it really depends. It's hard to say exactly, partial credit wise. But you do need to learn the interval notation, you know. Okay, so here's another one. Suppose we had 3x plus 7 divided by minus 4 is greater than 2. Suppose you want to solve that. Now, if I multiply by minus 4, what do I have to do? I have to flip the, so I get 3x plus 7. Instead of greater than, it becomes less than 2 times minus 4, right? So minus, yeah, subtract 7 from both sides, right? So we have 3x is less than minus 15. And then finally we divide by 3, right? And this time we don't have to do, oops, x minus 15 over 3 is minus 5. So there you go. Now that's not the answer yet, but I mean that's, you could write the answer like that. But that would not be interval notation. What would be interval notation? Yeah, negative infinity to minus 5, not included. That would be the solution set to this problem. Oh man, all my examples are working out the same. Let me try something else. Let's see here. Rats, this one worked out the same. All right, so example 3. Let's try out 1/2 x plus 1/3 x minus 1/5 times x plus 6 is greater than or equal to 1/10. So my advice on a problem like this is you want to look for the least common multiple of the denominators. So like we could try what, like
6.
Multiply by 6. Yeah, 6 would be good to make the half and the third go away, right?
Mm-hmm.
But then we'd still be stuck with like 6/10 and 6/5. So how about, what if we multiply by, what's that? Multiply by, yeah, like 30. I think 30 is the least common multiple of 2, 3, 5, and 10. So multiply by 30 is a good idea. Unless you want to add fractions. If you want to add fractions, more power to you. You could do that. But multiply by 30 is a good idea. This gives us 30 over 2 x plus 30 over 3 x minus 30 over 5 times x plus 6 is greater than or equal to 30 over 10. Distributing the 30 through. So then what? Well, 30 over 2 is what? So we've got ourselves a 15x plus 10x minus 6 times x plus 6 greater than or equal to 3. So let's just simplify that. Let's collapse this down a bit. This is 25x minus 6x minus 36 greater than or equal to 3. And then I think we should add 36 to both sides. Yeah. And then just clean that up. 25 minus 6 is 19. So I'll just add 36 to both sides. This gives me 19x greater than or equal to 39. Because 25 minus 6 is 19. Yeah, then exactly divide by 19. We get x greater than or equal to 39 over 19, right? So if we draw a number line, but do we? See, we don't, because we're dividing by a positive. But that's I mean, good to be thinking about that, but be careful. Only when we divide by negative, okay? So this means x is to the right of 39 over 19 on the number line, right? So it looks like that. So the solution here is 39 over 19, comma, infinity. There's your solution set. For me? Did somebody throw this up here or something? Or
I think for you, yeah, I think for you.
or is that just up here? So we're trying to see, I mean, it's not going to do it. No, thank you, though. It's okay. It's okay. I was, well, anyway, let me not start. One of my colleagues did have a student who offered him like $200 or $300 to give him a final exam early because he wanted to leave. He didn't want like anything. He didn't want anything easy or anything. He just wanted to take the exam early, and he's like, "I'll make it worth your while. I'll pay you $200." That won't work. Oh, $300. You know, yeah.
Is that possible?
No.
How do you know what side, when you're writing the solution set, like if it's going to be like positive or negative?
So it depends on whether the solutions go on off to the right. If they keep going to the right, that goes to plus infinity.
How do you know if it's going to keep going to the right?
Draw the number line. So, like this puts the number right, and that has to be. So I mean, look, maybe if we write it this way.
If x is greater than, it's always positive. If x is less than, it's always.
So if you if you write the solution using less than notation, the x will be to the side of the number where it's supposed to be. See this? That puts the x over there. This one, I use less than, right? That puts x where it's supposed to be relative to -5. I think, see over here, I use less than, right? X is on the right side. So if you use the less than notation, the inequality will match the number line. But otherwise, you just have to think through it. Like I just thought about it, this circled thing, I thought, well, if x is greater than or equal to 39 over 13, that means it's to the right of 39 over 13. So basically, you just have to be careful to not flip in your mind things you know for less than for things you know for greater than. Like if you don't pay attention to the distinction between those two, you can get confused. Example 4. As soon as I find a marker, which is working. Suppose we have x minus 6 less than 4 minus 2x less than x minus 10. All right. Can we solve this? All right. So I want to isolate x, yeah? So what I'm going to do is I'm going to subtract x across this, yeah? So minus x. So we get minus 6 is less than 4 minus 3x is less than minus 10. You really don't even have to go any further at this point. This is absurd. See, this statement right here, what's this say? This implies that minus 6 is less than minus 10. Is that true? It's not. Which means this inequality has the set you're talking about as its solution set. It has the empty set. So here, this is impossible. Solution set, no solution. There's no real number which satisfies that inequality. Let me take this example and modify it just a little bit. Now things are going to go better. Now we're going to find an answer. See, all I did was I changed that minus 10 to a plus 2. All right, things are going to work out different now. Again, subtract x across of it. Okay, minus 6 is less than 2. At least we're not going to get stuck there, yeah? Okay, great. Now I want to isolate the x, so how about subtract 4 across it, yeah? So minus 4. That gives me minus 10, less than minus 3x, less than minus 2. I subtracted 4, yep.
I have a question.
Uh-huh.
What if you added 2? Can you actually have 2 and get rid of 2?
Add,
That's not
add 2?
mathematically correct.
Oh, here?
Yeah.
Well, if you added 2, you could put a 0 here, but then that would just get you to, I mean, you could add 2 to that. That would get you to minus 8 is less than 2 minus 3x is less than 0. I mean, okay, true, but not what we're after. So we're trying to isolate x is the game. You want to isolate x, yeah? So now we just divide by minus 3. Careful, minus 3 is negative, so we have to flip the inequalities. So we get minus 10 over minus 3 greater than minus 3x over minus 3 greater than minus 2 over minus 3. Let me clean things up a bit here. So this gives us 10/3 is greater than x is greater than 2/3. Now, for reasons like you were asking me about, what's your name? What Maddie was asking me about, like in terms of picturing this, I think it's far healthier to write it in terms of less than. This is the same as 2/3 less than x less than 10/3. So I can picture it on the number line like it's going from 2/3 to 10/3, right? This is a picture of the solution. X is somewhere in here. My solution set is what? Two-thirds, comma 10/3. There you go. So at this point in the previous lecture, somebody was like, "Oh, I'm enjoying this. This is so much better than last week." How do you feel? Do you feel like that? Yeah?
Yeah, I was going to ask a question. Am I making this up, or is there a case where you can have
two sets where it's negative infinity to 5 and then 5 to infinity?
That could happen.
Okay, and like in what case would that happen?
None of these. Yes, she was asking, could you have like two disjoint cases where we need a union to join them? And yeah, that can happen. However, probably not with these linear inequalities, unless we bring absolute value into the story. But absolute value really is just a nonlinear thing in disguise, truth be told. We'll talk more about that next time. But last class, they were reveling in the fact there was no factoring so far in this lecture, and that is true, but that's about to come to an end because the next chapter in this saga is nonlinear inequalities. So what we've solved so far today, nonlinear, curses, nonlinear inequalities. So what we've been solving today so far, I would classify as linear inequalities. So like examples 1 through, I can't count, it's 5. These were all linear inequalities. They just involve multiplying the variable by a number and adding stuff, right? It's like y equals mx plus b kind of math, all right? And we could solve these by doing what? What's the method for solving those? Pretty simple, right? Isolate x, right? Yeah. I mean, we use the laws of inequalities to isolate x. Nonlinear inequalities, though, we're going to need a more subtle technique. So here's the technique we're going to use. Number 1, we're going to identify all algebraic critical numbers. And by that, I mean these either give 0 or undefined for the expression. All right. So you look for numbers which either make your expression 0 or undefined. All right. Step number 1. Step number 2 is you write number line which has all critical numbers marked. All right? You mark down each one. Step number 3, you test a number in each case, which are each case between the critical numbers. And I will put parenthetically, or cheat, test 1, and use odd factor implies flip sign, even factor implies no flip. All right. And then step 4, write down answer. Now, to be clear, case 3 also is you test a number in each case between critical numbers and you write plus or minus as appropriate. All right. Now, listen, this is totally vague until I give you examples to flesh this out, all right? I need to give you examples. Let's see here. So example 6. Suppose we're solving x squared minus 3x plus 2 greater than 0. So here, as I'm looking for my algebraic critical numbers, or I say algebraic critical numbers, but I could just say critical numbers because we're only going to talk about algebraic critical numbers in this course anyway. So let's just say critical numbers. Critical numbers here. X squared minus 3x plus 2. Are there any x for which that's not defined? No. I mean, this is the domain of this expression is all reals. So we don't have to worry about undefined. All we have to worry about is where it's 0. How do you figure out where that's 0? Remember, we factor. So this is x what? Minus 1, minus 2, yeah? So what are my critical numbers? Yeah, the critical numbers are 1 and 2. Because remember, they're opposite the sign of what appears in the factor, right? That's the number I put in to get 0. If a minus 1 appears in the factor, the critical number is 1. Minus 2 appears in the factor, the critical number is 2. Okay, we have now achieved step number 1. Hooray. Step number 2, write the number line. Like so. Here's 1. Here's 2. It is important that you put your numbers in order. This seems like a small thing, but if you put the numbers out of order, this is no longer a helpful method. It's just very misleading. Put your numbers in order. 1 comes before 2. We all agree, right? You know anybody that's turned 2 years old before they turn 1? Not usually, right? It's got to be a movie somewhere where it happened. I don't know. Okay, now what? Test a number in each case. All right, so I'm going to test a number in each case. I'm not going to use my trick yet. So what's a number over here? How about 0? That's over there. Plug it in. When you plug in 0, we get what? 0 minus 1, 0 minus 2. So we get, of course we could just put it up in here, right? Plug in 0, what you get? You get 2, right? So we've got pluses. All right. What's a number between 1 and 2? 1.5, very popular choice, right? So you plug 1.6. You're just being contrary, aren't you? What's that? What's that? I wanted you to zig. You decided to zag instead. I get it. Let's see here. 1.5 minus 1, 0.5. 1.5 minus 2, negative 0.5. So you got yourself plus and a minus. Plus minus is minus. So you plug it in, you get a negative number. I don't really care what the negative number is. I just need to do enough of the arithmetic to see that it's a negative number. Right? And then what's another thing we could plug in? I need some number over here to the right of 2. 3, yeah. So for those of you who are trying to understand what we're doing, you might be asking yourself, where did 0 come from? Where did 1.5 come from? Where did 3 come from? What were those? Those are, we just picked them, right? Just random. Well, they're not totally random in the sense that they do have to be in this case. It does have to be some number to the left of 1. It does have to be some number between 1 and 2. It does have to be some number to the right of 2 for this. I mean, you need a number in each case. So if I plug in 3 here, I get 3 minus 1, which is 2, 3 minus 2, which is 1, 2 times 1 is 2. Of course, that's positive, right? All right, so we have filled out our sign chart. So we've done number 3. 3 is done. Now we can write the answer down. The answer is solution set equals minus infinity to 1, not included, unioned with 2 to infinity. So this is what you're asking me about, right? You wanted an answer like this? So you can get an answer like this, but we need a nonlinear inequality, or a pair of linear inequalities which are disjoint. There's a way to make this happen for linear ones too, if you use the right language. Like, so since you asked this question, another way you could do is if you had like x such that x was less than minus 4, or x was greater than or equal to 10, if the problem was worded like that, then this would also be equal to minus infinity to minus 4 not included, union with 10 to infinity.
But you never have negative infinity to 1 and then 1 to infinity, right? That's just all real numbers.
If you had negative infinity to 1,
If you took the 2 and just turned it into a 1, you never have that, because that would be all real numbers, right? Because it's all included.
oh,
That's what I'm asking. Because I don't know.
okay. Let me come back to, I'm going to circle back to that. Example 8, before let me just exhaust this problem. What happens if I do x squared 3x plus 2? I'm going to come back to your question here in just a second. But what if instead of having greater than or 0, I trade that for a less than or equal to 0? See, that is a related but different problem to example 6. What would the solution be?
Wait, it's number 7. Is the answer what the negative?
Oh, this?
Yes.
That is this set in interval notation.
Okay, sweet. All right, thank you.
Well, now it's right.
Notice that this word or is important. Or. If you replace that or with an and, the answer is nothing. There is no x which is simultaneously less than minus 4 and greater than equal to 10. You can't have both at the same time.
The guy between 1 and 2.
Yeah. So this one here, look, the answer to this problem is already given up here. You look at that, you go, when is x squared plus minus 3x plus 2, same things here, right? This is the critical numbers, this is the signs. When is it less than or equal to 0? Here to here. So the solution is 1 to 2 with the 1 and the 2 included. We include the 1 and the 2 because we had equals to as a possibility here, right? So we could have 0, that's okay. I've been thinking about your question. So your question prompts me to make a weird example, which is fine. Hopefully I can do it.
I just wanted to know if I was going crazy or not actually doing the example like that.
Oh, I don't know. It depends on, which mathematical dark alley you've walked down. I don't know, like, depends. I mean, such examples exist. How about this? If we look at the solution to just say x minus 1 squared greater than 0. Okay? So this is very silly. The critical number is 1, right? And if you check any number over here, like 2, or over here, like, I don't know, 0, right? What do you get? So I'll write it down here. 0 minus 1 squared is what? 1. 2 minus 1 squared is 1, right? So it's pluses here, and it's pluses here. So you might be tempted to say that the answer is everything, but it's not, right? Because, you've got to think about this carefully, greater than, right? So equals to 0 is not allowed. See, x equals to 1 gives, minus 1 minus 1 squared equals to 0, right? Which is not greater than 0. 0 is not greater than 0. So 1 has to be excluded here. This problem has solution set. Minus infinity all the way to 1, union 1 to infinity. So that could happen. Doesn't usually, but it could. In contrast, like this one, we're missing all these numbers between 1 and 2 for that solution, right? And all those numbers between 1 and 2 are the solution to the corresponding complementary problem down here. All right, I was talking about a sign flip. Sign flip. Check this out. So both of these are odd factors to the first power to the first power, right? Notice that as we go across 1, we change from plus to minus, and then from minus to plus. In contrast, this is an even power. As we go across the critical number, plus to plus, no flip. If you understand this, you can fill out the sign chart by just taking one test point and propagating using the sign flip rule. So like here is a formidable example to end our day with. X minus 1 squared, x plus 3 to the 7th power divided by, oh, I don't know, x minus 10 to the 7th power to the 4th power, x plus 18 to the 3rd power. All right, greater than 0. Solve this thing. Now, the reason this problem is like reasonable to ask in here is I factored it already. It came factored, so you can easily put into practice the algorithm. So here we go. We write down a number line. We write down our critical number. What are the critical numbers here? I've got a 1, a minus 3, a 10, minus 18. Now, this is important. You need to put those in order. Which one comes first, left or right? Negative 18. All right, good. Then negative 3 comes next, right? Then 1, and then 10. Now, is my number line to scale? No. Does it matter? It does not. All right, now here's the cool thing. Pick any point you like to plug in the number. What's the easiest thing to plug into something usually? Yeah, I like 0. Where's 0? 0's right up in here, yeah. So if I plug 0 into that, I get minus 1 squared, 3 to the 7th power, minus 10 to the 4th power, 18 to the 3rd power. This is for x equal to 0, right? Which is what? Plus over plus over plus. It's plus. All right, so pluses. Positive in that case. All right, now I'm going to use the sign flip rule to generate the rest of the signs. Sign flip rule. 1. 1 is an even power because x minus 1 squared, which means we stay positive as we cross that 1. So because I have an x minus 1 squared, the sign flip rule says as you transition from one side to the other, you maintain the sign. I figured out the red pluses by plugging in the number. So it follows I get the blue pluses for free. In contrast, minus 3 is corresponding to x plus 3 to the 7th power. That is an odd power. Flip the signs. So we go minuses over here.
So the first one on the even power, so
Right, yeah. Now, how about this though? Now we get to minus 18. That's the power that matters, right? Not the number, the power. 3. Odd. So we flip. Negatives to pluses. So we got pluses over here. 10. Going from one side of 10 to the other, what happens? Yeah, we got 4th power. That's even power, so no flippy flop. Just stay positive. Let's make this greater than or equal to 0 for fun. All right. What is the solution? I told you I'd go a minute over. You're like, you don't actually have to stick to that, right? See. Sorry, guys. Minus infinity to minus 18. Do I include or exclude 18? We have to exclude minus 18 because that corresponds to division by 0, which we do not do. So we must exclude minus 18 because of division by 0. That's a division by 0. We do not want the minus 18. What's next? minus 3 to 1, right? Do I include or exclude minus 3? I can include that because I'm looking for 0. 0 is a possibility here, right? So include minus 3 because we want that. How about 1? Oh, 1's also fine because that's equal to 0. So we can include both minus 1 and, minus 3 and 1. And then union what? 1 to 10, right? Now is 1 included? Well, we just said 1 was included, didn't we? 10, is 10 included? 10's trouble, division by 0 there, so we have to exclude that. And then 10 to infinity, we also get.
Wait, how do you know how to exclude or include something?
If there's division by 0, you got to throw it out. If it's just 0, you might include it, depending on whether the question allows for equality or not.
Where did you get the division by 0?
How do you what?
Can you show like the division by 0? Is there like word for it?
It's just right here, right here. So if I plug in 10, we get division by 0. So we just look at the factored form. If you have a factor correspond in the denominator,
So it's just doing 10 minus 10.
yeah, the division by 0 either comes from 10 or minus 18. Those are your troublemakers. Remember the division? Remember the domain questions in the last homework?
Yeah.
Same thing, same thing. It's the divides by 0 you had to throw out, just like that here. Now, this guys, we could take this right here, and you could rewrite that as minus 3 to 10, if you wanted. These two pieces can be combined like that. Anyway, yep.
Could the 10 and 10 be combined too? Or
Could the what?
could the 10 and 10 be combined too?
No, these cannot be combined. We have to throw out 10.
Okay.
We have to throw out 10. So like, so that would be my answer. Thanks, guys. Can you hit record? You hit the button? Thanks.